Let's begin by looking at velocity. First, a couple of important scientists from the past. Galileo Galilei lived in the 16th century mainly, and he experimented with gravity. The year he died, Isaac Newton was born. This mask here is called a death mask, and they have traditions in some countries where when a person died, they would put plaster over their face so they would have an image of the person. This is Newton's death mask. Some definitions for us that we'll be using in physics. Mechanics, the study of motion, of the motion of objects and the related concepts of force and energy. A subgroup of that is kinematics. And kinematics is the study of how objects move, while dynamics is a study of the force and why objects move as they do. So currently we're studying mechanics and specifically kinematics. Another definition is displacement. Displacement is the change in a position. So for example, we have a dog that runs 30 meters to pick up the stick and returns 26 meters. Doesn't come quite back to you. So a little animation for you. Off goes your dog, 30 meters in one direction. He comes back to you, 26 meters. His displacement is 4 meters. He does that in a time interval of delta t. TF stands for final time, TI is initial time. Now distance is the total distance traveled. So if we use the same animation, this time the dog runs that 30 meters, comes back to you, 26 meters, but this time his distance that he ran was 56 meters. So in the second section of the physics books, we look at average velocity. But first, let's define average speed. Average speed is the distance traveled over the time elapsed. We say speed only has magnitude, which means it only tells you how fast. It doesn't tell you which direction the object is going. On the other hand, average velocity does give you magnitude and direction. Magnitude, again, is how big it is. So our average velocity is equal to the change in displacement over the time elapsed, which is the final position minus the initial position over the time elapsed. Our equation looks something like this. This little bar over the V means the average. Notice the V is in italics, it's lowercase. dF stands for final displacement minus initial displacement over elapsed time. We usually just say change in position over change in time. I will be giving you an equation sheet in class next time I see you. So you'll have this right in front of you. Let's work an example. Our first example. During a 2-second time interval, the runner's position changes from 50 meters to 60 meters. What is the runner's average velocity? So we should have an apostrophe there. Whatever. Okay, so I like to list all my variables, and I think I've done that. DI, DF, and a delta T. So DI is 50. Final position is 60 meters. And our time interval is 2 seconds. So our average velocity is equal to our change in position over a change in time. I'm going to write it dF minus di over delta t. So let's plug in our numbers. we have 60 meters for our final position minus 50 meters for our initial position divided by 2 seconds. Now you can see that that's 10 divided by 2, which is 5. Thinking about sig figs, we should have 3. And our units, 5 meters per second. And that's our average velocity. Let's look at another example. How far can a cyclist travel in 2.5 hours along a straight road if her average velocity is 18 kilometers per hour? So we know our average velocity, we know the time interval, and we want to know how far, her displacement. So let's list what we know. Velocity is 18.0 kilometers per hour. Delta T, 2.50 hours. And our delta D, our displacement, is our unknown, or our x. Our basic equation, average velocity, and I'm going to leave off the little hat showing me that it's average, is delta D over delta T. In physics, we want to rearrange our equation before we solve for it. So we want to solve for delta D. So I'm going to bring the delta T over by the V. So I have V times T is going to give us our change in position. I'm going to just bring the D to the other side, write it like this, V delta T. You might know this as rate times time gives you distance. In this case, we're just looking at displacement. So delta D is equal to, our average velocity is 18.0 kilometers per hour. Notice how I write it so I can look at my units more closely. Times 2.50 hours. Before I do the math, I'm just checking my units, doing some unit analysis, making sure I get kilometers. So now, 18 times 2.5 is 45, and we need 3 sig figs, kilometers. So she moved 45 kilometers in 2.5 hours. Sorry, I don't know where that went. Let me know if you need to see that again. Sorry. All right. One more definition for this section, instantaneous velocity. If you're taking calculus, you'll be studying this. I'll just mention it to you guys. The speed and direction of an object at a particular instance. Let's take you driving to school again. There's moments where you might be going 65 miles per hour and other moments where you're going 25 miles per hour. If we look at where you are at a moment in time, that would be your instantaneous velocity. All right, let's look at acceleration in the next video.